Accurate weather forecasts are very important for sailors. Their predictions determine whether we set off on a passage, or wait for better weather. The information is used to pick a safe anchorage in which to shelter from a storm, or to identify a nice day to go for a cruise with friends. We place a lot at risk on the information we are given, so why can some forecasts be so different, and why do we sometimes get completely different weather to what we were expecting? Let's learn more about forecasting. If you have been following my other meteorology course posts, then you will already know that the weather we experience is a complex recipe of many different forces at work all around the world. Temperature, air pressure, seasons, the Earth's spin, ocean currents, moisture all mixing together. With all these different weather ingredients mixing together in unequal measures, it is no wonder that the end product can be quite difficult to predict. Forecasts use current weather observations from all over the globe and then run that collected data through computer-generated models to estimate what is going to happen in the future. The current weather is observed from weather stations on land, weather buoys at sea and satellites in space. This is standardized by the World Meteorological Organization, a specialized agency of the United Nations to facilitate the global exchange of weather information. A good example of a local weather station is the Littleton Port Company weather page, providing current and past weather statistics and a 48-hour forecast. Weather stations provides hourly current weather information such as the temperature, dew point, wind speed and direction, cloud types and height, visibility, precipitation, swell, sea state, lightning and barometric pressure. Satellites provide a global view and meteorological radar can provide information rain location and intensity. Upper air soundings from weather balloons are also used. Ships and planes can also provide weather data as they travel around the globe. Once this data is collected, it is loaded into the weather model as a starting point for a forecast. The model uses things called primitive equations to determine rates of change in the atmosphere. This gives a prediction a short time in the future. The equations are used again on the predicted forecast to get another result for slightly further into the future, and so on until you get a forecast for up to the 10th of July 12 days into the future. The charts that these models produce are called prognostic charts. This raw data is then usually combined with human interpretation and modifications taking into account local influences, such as mountain ranges, or areas where wind is known to funnel, and this is then produced as a forecast. The trouble with the nature of these models is that weather dynamics are extremely chaotic in nature, and even a slight error in one of the weather observations can create vast anomalies in the mathematical models, particularly the further into the future they attempt to predict. Therefore, numerical models can only ever produce approximate solutions.